Before we will start doing actual problems, I would like to recall a few things. You have to be very careful to distinguish between the always true and the snapshot, which is true only on a very short instant of time. Everything that is always true in the snapshot, but whatever is true in the snapshot is not true in the always true. Here is our first example. Two friends are going home after spending time together. One walks north at the rate of 4 miles per hour, and the other bikes east at the rate of 10 miles per hour. How fast is the distance between the two friends increasing after 2 hours? Let's start as usual with the always true. First, we have to draw, label, and see what is given. Let's be x the distance and y it's the other distance. X is the distance from the starting point that related to the friend who walks, and the y is the distance from the starting point that related to the friend that bikes. We need to find the distance. This is going to be capital D. It is given the dx dt is the walking rate, which is 4 miles per hour, and dy dt is the biking rate, which is 10 miles per hour. The main equation is the equation that have to connect x, y, and d. X is a function of t, y is a function of t, and d is a function of t. And it is Pythagorean theorem. Now we're differentiating everything with respect to t. X, y, and d are all functions of t, and we get that. We can cancel the 2, simplify, and we can solve here if we like. We would like to find the rate of the distance, which means that we need to find dd dt. And if we solve that, we get that. Now we would like to take the snapshot. In the snapshot, we are going to substitute everything that is related to the specific instant. Now the only thing that we know is that the snapshot should be taken after 2 hours from the start. So what happened after 2 hours? dx dt is 4, so I can substitute that. And the rate of the biking is 10, so I can substitute that as well already. I still have no idea what is x, y, and d. But I can find it by doing another drawing that describes exactly the instant that is exactly 2 hours after the start. After 2 hours, this is 8 miles, and the reason is because if the rate of walking is 4 miles per hour after 2 hours, the distance from the start is 8 miles. What about the y? After 2 hours, if the rate of biking is 10 miles per hour, the distance from the start is going to be 20 miles. So this is 20. And to find d, I can apply now Pythagorean theorem. It is the square root of 8 to the power of 2 plus 20 to the power of 2, and I get square root of 464 miles. Now I can calculate the number, and I get that, and the unit is miles per hour. Please again be careful with the snapshot. You have to view this as if the person that is walking is still walking north at the same rate, and the person that is bikes is still biking exactly the same as before with the rate of 10 miles per hour. But in the snapshot, we are just taking a snapshot. We are not changing the going on process that continues forever. The answer: after 2 hours, the distance is increasing at a rate of 232 over square root of 464 miles per hour. Example: an observer 100 feet from an hot air balloon is looking as it is rising from the ground at the rate of 5 feet per second. How fast is the angle of elevation increasing when it is pi over 4 radians? Let's start with what is always true, and it is including the drawing, labeling, and what is given. dH/dt is 5 feet per second because the balloon is rising from the ground at the rate of 5 feet per second. Here's the picture. The observer is 100 feet and he sees that the balloon is rising from the ground. H is the height of the balloon and theta is the angle of elevation. What is the main equation? Because we have theta, it must be some trigonometric function. If you see, there are two known sides, 100 feet and h. So to connect that, we have to use the tangent function or the cotangent function. But the tangent is okay. Tangent theta is h over 100. Both theta and h are depending on time. Now we're going to differentiate. We will get secant to the power of 2 of theta, d theta dt, because theta is a function of t. And this equals 1 over 100, it's just a constant. And when differentiate h, we get dh dt. Now we would like to focus our attention to the snapshot. In the snapshot, if you can see, theta is pi over 4. dh dt is always the same. It's always 5 feet per second. So you can see this from the problem or from what is given. And it's written in the always true. So now we just have to substitute in. We will substitute this for the theta and this for dh dt. And we calculate that. And we are solving for d theta dt. We get the d theta dt is 1 over 40 radians per second. The answer then? The angle of elevation is increasing at the rate of 1 over 40 radians per second. Example: a ladder of length 6 feet is leaning against a vertical wall and sliding down. How fast is the top end of the ladder moving when its bottom is 2 feet from the wall and moving away from the wall at a rate of 1 feet per second? Let's start with the always true. You probably would like to read the problem again to understand again what's going on. And then we need to start drawing, labeling, and see what is given. A good picture here is a must. First of all, there is a wall and there's the floor. And here's our ladder, which is 6 feet. Pay attention, this is the constant length of the ladder. 6 feet is not going to change because the ladder does not change its length. But it is moving. it is sliding down, which means that the tip is going that way. And when this happens, because it's 6 feet, then it has to be that the bottom is also sliding farther from the wall. So this is the right direction. You have to be now really careful. We're going to label this by x, so x is going to be the distance from the wall to the bottom of the ladder. And this is going to be y, which is the distance from the floor to the tip of the ladder. What is the main equation? You can see easily that this is again Pythagorean theorem. X to the power of 2 plus y to the power of 2 equals 6 to the power of 2. We differentiate both sides. Be careful. It's easy to see that we get 2x dx dt plus 2y dy dt, but please note that the derivative of 6 to the power of 2, because 6 to the power of 2 is just a constant, it's 36, is 0. And again, I will repeat, the length of the ladder is not a function of t. We can just cancel 2 and get that. Now we have to move to the snapshot. If you look, everything is related when the bottom is 2 feet from the wall, so x is 2 feet. Dx dt is 1 feet per second, because it is moving at that instant at a rate of 1 feet per second. It is increasing. You can see that the distance of the bottom of the ladder and the wall is increasing. But pay extra attention to dy dt. What is dy dt? This is what you have to find, but be careful with the y. We have to find it. Because x now is equals 2, we can find the y. It is 36 minus 4, and then we have to take the square root, and we get that y is the square root of 32 feet. Now we can substitute this instead of the question mark or the y. And now we can solve for dy dt. Dy dt is negative 2 over square root of 32. 32 is 4 times 8, so we can cancel 2 and we get negative 1 over square root of 8 feet per second. We can actually check kind of the answer. Dy dt has to be negative. Because the ladder is sliding down, it means that the distance between the top of the ladder and the floor is decreasing. And the answer is that the top of the ladder is sliding down at a rate of 1 over square root of 8 feet per second.